Hi guys, how's it going? So in this tutorial I'm gonna show you how to solve question number 13 on the waters practice exam that we posted about a week ago. And there's quite a few ways to solve this question. Um, First I'm gonna show you the long way, the hard way to do it, in which you go from a Newman projection to a Sawhorse projection, and then I'll show you the very easy way, okay? So yeah, let's get started. I'm gonna focus on the Newman projection on the left, and as you can see in carbon 2 the methyl group is going up, the hydrogen is on the right, the OH group is on the left, and so I'm gonna draw this as a Sawhorse projection, and I'm gonna draw the methyl group coming out of the page, the H group receding away, and the OH group on the plane of the paper. And so here's our methyl group. Now we're gonna draw the OH group. And finally, after this, we're gonna draw the hydrogen receding away from us. Now I want you to see that the methyl group on carbon number 3 is anti to the OH group on carbon number 2, and so we're gonna draw it opposite of it, so 180 degrees away from the OH group. It's gonna be on the plane of the page, but anti to the OH group in carbon number 2. And because the OH group on carbon number 3 is anti to the methyl group on carbon number 2 on the Newman projection, we can expect it to be a dash. And on the Newman projection, you can very clearly see that both hydrogens are anti to each other. And on carbon number 2, I drew the hydrogen as a dash, so you can expect the hydrogen on carbon 3 to be a wedge. Now you can go ahead and assign priorities, pause the video, and you'll realize that both of these have an R configuration. Now the hard part is over. What you need to do now is pretend that there's a mirror on the right of this molecule and begin to draw its enantiomer. And after a bit of work, you realize that the molecule on the right has the SS configuration. However, now we need to verify that the Newman projection on the right is the same as the Sawhorse projection below that I drew on the right. And so let's verify. So methyl group on the carbon on the left is anti to the OH group on the carbon on the right, which is good for the Newman projection. Now on the Newman projection we can see that both hydrogens are anti to each other, and on the Sawhorse projection I drew below, the hydrogen on carbon on the left is anti to the hydrogen on the carbon on the right, and so we got that one right as well. Now let's look at the OH group on the first carbon on the left, and we can see that it's anti to the methyl group on the carbon on the right, which matches the Newman projection as well. And after that tedious amount of work, you realize that both of these compounds are enantiomers, because the one on the left has the RR configuration, the one on the right has the SS configuration. They're non-superimposable mirror images of each other. However, that was a lot of work, and there's an even easier way to solve this question. And you can simply look at carbon 2, and you see that it has 4 different substituents, and then carbon number 3, the one in the circle in the back on the left, it also has 4 different substituents. And you can, just by looking at the mirror plane, you'll see that the molecule on the right is a mirror image of the molecule on the left, and you know that a property of chiral compounds is for their mirror image to be an enantiomer. And so yeah, that's the second way to do it. It's a lot simpler, but just be very careful. Anyway, I hope that was helpful for you. and I will see you on Monday. Bye bye.